the vast expanse of the universe, light speed is not just a concept from science fiction, but a crucial key to unlocking the mysteries beyond our solar system. Imagine a world where journeys to distant galaxies become not just possible, but a reality. NASA, our leading space agency, has recently revealed something that might just change the course of space exploration forever. Dive deep with us as we explore 10 groundbreaking facts about NASA's ambitious plans to reach the seemingly unattainable, the speed of light, through revolutionary futuristic technology. Number 1. The immensity of space and the need for advanced propulsion. The expanse of our universe is almost concept of a light year. A light year, contrary to what the name might suggest, isn't a measure of time, but of distance. It represents the distance that light, the fastest thing in the known universe, travels in 1 year, about 588 trillion miles or 9.46 trillion kilometers. When we say our closest star, Proxima Centauri, is approximately 4.2 light years away, we're saying that, traveling at the speed of light, it would take 4.2 years to reach it. But here's the terrifying part. Even with the fastest spacecrafts we've ever built, such as the Parker Solar Probe, which speeds at about 430,000 miles per hour, it would take thousands of years to reach Proxima Centauri. This brings us to a pressing challenge: our conventional methods of propulsion. The inefficiency of these methods becomes glaringly obvious. Necessity for meaningful exploration beyond our solar system. And so, as NASA peers into the vast, intimidating theater of space, they are not deterred, but rather inspired. Inspired to think beyond, to innovate, and to dream of a future where these distances are not barriers, but gateways. A future where the immense space isn't a void that isolates us, but a canvas waiting to be explored. And with their recent revelation of a technology so advanced it can potentially reach light speed, we might just be on the precipice of turning this dream into a reality. Number 2. The helical engine, a potential game changer. The exploration of deep space has been an aspiration of humankind for generations. As NASA continues to push the boundaries of human knowledge and technology, the helical engine emerges as a promising avenue for back. It does so with its original mass. This continuous alteration in mass generates thrust, much like how a submarine uses its propellers to push through water. This concept, though deceptively simple in its explanation, can lead to significant propulsion if applied correctly. The genius behind this revolutionary idea is David Burns, a NASA engineer. With a keen understanding of the complexities of space travel and the challenges it presents, Burns proposed this engine as a theoretical solution to achieving almost unimaginable speeds in space. In his vision, given the right conditions, ample time, and an adequate power supply, the helical engine could potentially propel a spacecraft to speeds approximating 99% the speed of light. That's nearly 671 million miles per hour. Though it sounds like something out of a science fiction novel, the helical engine underscores the potential future of spaceables that, on paper, may seem like an intricate dance of physics. However, breaking it down, it's reminiscent of a box with a weight inside, situated in a vacuum. Picture this. Within this conceptual box, a weight is continuously moving back and forth, connected by something akin to springs. It's this perpetual motion and mass-altering processes occurring at near-light speeds that allow the helical engine to generate thrust based on the principles of special relativity. The sheer scale and energy demands of the helical engine are nothing short of monumental. It's not something that could be easily housed in your typical spacecraft. In fact, it would need to be massive, spanning over 200 meters in length and approximately 12 meters in diameter. The power requirement is just as formidable. For the helical engine to achieve useful speeds, a helical engine could truly showcase its potential. This, however, also underscores its limitation. On Earth, with our atmosphere and gravitational pull, its functionality is inhibited. But out there, amidst the stars, the helical engine could very well be our ticket to the far reaches of the universe. Number 4. Past ventures, the M drive. In the relentless pursuit of space exploration, NASA has often been at the forefront of investigating groundbreaking technologies, one of which is the M drive. A revolutionary propulsion system, the M drive stands out not only for its avant-garde concept, but also for the questions and controversies it stirs up within the scientific community. The essence of the M drive's operation is both fascinating and, to some, puzzling. Instead of relying on traditional fuel or exhaust methods commonly, one of the primary challenges faced by this innovation is the immense heat it produces. Managing and dissipating this heat is crucial, especially in the cold vacuum of space, where there's no external medium to aid in cooling. The skepticism extends beyond just practical concerns. The way the M drive functions appears to defy the conventional laws of physics, particularly Newton's third law, which states that for every action, there's an equal and opposite reaction. How can a drive provide thrust without expelling any material in the opposite direction? While the M drive has ignited hope for a futuristic propulsion system that might redefine space travel, the scientific community remains divided. The next steps for this technology involve rigorous testing, validation, and potentially rewriting some of what we understand about propulsion physics. Regardless of the outcome, the M drive undenied and mysteries yet to be unraveled. One such enigma that has captured the attention of astronomers and space enthusiasts alike is Proxima b. Touted as a breakthrough in our understanding of celestial bodies, the discovery of Proxima b is not just another notch in the belt of space exploration. It represents a potential second home for humanity. Located within the habitable zone of Proxima Centauri, its parent star, Proxima b has the potential to possess conditions conducive to life. Such a revelation emphasizes the significance of this exoplanet, elevating it to more than just a point of interest. It becomes a beacon of hope, a tantalizing hint that we might not be alone in this vast cosmos. Recognizing the immense promise and allure of Proxima b, NASA has unveiled plans that might have seemed audacious even a decade ago. By 2069, they aim to launch a robotic zone, is a challenge that NASA is eager to embrace. Through this mission, NASA isn't just setting its sights on the stars, it's aiming to redefine our very understanding of space, time, and our place within the universe. Number 6. Alternative propulsion. The solar sail. In the vast arena of interstellar exploration, where distances are so staggering that even light takes years to traverse, conventional rocketry falls short. But hope gleams brightly in the form of the solar sail. This isn't your typical means of propulsion. Instead of burning fuel, the solar sail taps into the power of photons, tiny packets of energy from the sun. It's akin to a ship harnessing wind, but instead, this ship captures light. One name emerges as a torchbearer for this ambitious endeavor: Yuri Milner. His breakthrough, but with great innovation comes great challenges. The extreme force exerted by the lasers on such a minuscule structure requires the sail to be exceptionally robust. It must endure not just the thrust, but also the extreme heat generated during this process. Think of it as trying to catch a storm with a piece of paper. The sail needs to remain unyielding yet flexible. That's no small feat. It's a delicate dance of physics, materials science, and engineering. Yet if conquered, this technology could usher in a new era of space exploration. Imagine reaching the closest star systems in a human lifetime. It's a thrilling yet terrifying prospect, underlining humanity's relentless quest to go further, pushing the boundaries of the possible. Number 7. The theoretical Alcubierre warp drive and its implications. As space enthusiasts, we've long been captivated by the idea of The fascinating aspect here is that the ship doesn't move within the bubble, but rather it's the space around it that moves. Miguel Alcubierre, a theoretical physicist, proposed this idea in the mid-1990s. Drawing from Einstein's theory of general relativity, which postulates that massive objects can warp the fabric of space-time, Alcubierre suggested that if we could manipulate this warping, we could essentially move space. This movement of space-time would allow us to achieve apparent superluminal speeds without violating any fundamental laws of physics. Yet the original concept had its limitations, mainly concerning the enormous amount of negative energy required. But recent advancements present a new model, one that involves space-time bubbles. These bubbles, instead of requiring an immense amount of energy, might be achievable with vastness, and mysteries might someday be within our reach, making the stars not so distant after all. Number 8. The current landscape of space travel speeds. In the vast expanse of our universe, humankind's endeavors to traverse the interstellar void have been considerably restricted by the limitations of traditional rocketry. While rockets have been instrumental in enabling us to explore our immediate celestial neighborhood, their utility drastically diminishes when we gaze beyond our solar system. The very mechanisms that make rockets viable for moon landings and sending rovers to Mars become painfully inadequate for journeys to distant stars. Take, for instance, the nearest star system to us, the Alpha Centauri system. It lies at a staggering distance of 4.2 light-years away. Even if we were to dispatch a spacecraft at the speed of our fastest probes, like the Voyager 1, it would take more than 70,000 years to emphasize a profound realization. Using current propulsion technology, even the nearest cosmic destinations remain tantalizingly out of reach. Our most advanced rockets, operating on combustion principles, can't significantly shorten these immense travel durations. This stark limitation underscores the imperative need for breakthroughs in propulsion technologies if we are to entertain serious ambitions of becoming an interstellar species. The galaxies beckon, but our current means of travel make them little more than distant, untouchable dreams. The quest, therefore, isn't merely about reaching faster speeds, but reimagining the very fabric of how we voyage across the cosmos. Number 9. Potential life beyond, the curiosity surrounding Proxima b. Proxima b stands as one of the most tantalizing ingredients for life as we know it. However, it's not all rosy prospects for Proxima b. The exoplanet faces a significant challenge: the high-energy radiation it receives from its star. Proxima Centauri is a red dwarf, known for their temperamental nature. These stars can unleash powerful flares, which would bombard Proxima b with intense radiation, far stronger than what Earth receives from the Sun. Such high levels of radiation pose a risk to any potential atmosphere Proxima b might have, potentially stripping it away over time and thereby decreasing the chances of life-sustaining conditions. Yet the universe often surprises us. While the radiation levels might seem detrimental, it doesn't rule out the possibility of life. Life on Earth, for instance, thrives in some of the most extreme conditions, from deep-sea vents to radioactive sites. Thus, the vastness of space and the distances between stars are both awe-inspiring and daunting. When traveling at velocities approaching the speed of light, an incredible phenomenon occurs: time dilation. This relativistic effect means that for travelers on a spaceship moving close to light speed, time would seem to pass normally. However, for those observing from a stationary point, like Earth, more time would have elapsed. This means a journey that feels like just a few years for the space travelers could equate to decades or even centuries on Earth. It's a concept that challenges our understanding of time and underscores the mind-bending reality of relativistic travel. But this fascinating glimpse into the relativity of time is just one of the myriad challenges of long-duration space journeys. Prolonged space missions bring with them a host of logistical concerns. Looking for innovative solutions and studying the human psyche to prepare for such scenarios. At the heart of all these discussions lies the critical element: propulsion. Current propulsion methods, relying on traditional rocketry, are simply not adequate for interstellar voyages. The incredible distances demand advanced propulsion systems that can sustain high speeds over extended periods. Without these, reaching even the nearest stars remains an unattainable dream. But with the likes of the helical engine and other groundbreaking concepts on the horizon, the future of interstellar travel holds promise. It's a testament to human ingenuity and our unyielding desire to explore the cosmos. Thanks for watching, and while you are still here, make sure to click the video on your screen for more mind-blowing videos. I'll see you there.